This is section 2.2, part 2, and we are going to classify lines using slope. So what does it mean to classify lines? When you classify a line, basically you're going to say whether it rises, falls, it's horizontal, or it's vertical. That's going to be the classification of the line. And you will be able to do that just by looking at the slope, not even graphing it, but by looking at it. So to give us a visual representation, I'm going to show you the graphs of both positive and negative slopes, as well as zero slopes and undefined slopes. So let's start with the visual. You can see I've got two XY coordinate planes drawn here. Alright, let's focus on the first one. We've got this XY coordinate plane right here, and we can see our line is drawn in green. Alright, and that's our graphed line right there. And we can see the line is doing what from left to right? As you look at it from left to right, this line is rising. So I'm going to tell you this line is a positive slope. Alright, it has a positive slope, and we know that because it rises from left to right. So we know a positive slope rises from left to right. So when we were to classify this line, we have a positive slope. We can say, oh, the line rises, and that would help classify it. The next XY coordinate plane, we can see the graphed line, and looking at it from left to right, what's happening to this line? It's falling. So you're probably guessing by now that this is a negative slope, and you're right. Alright, we have a negative slope here. And we know negative slopes fall from left to right. Okay, we're going to go down to the next two coordinate planes. And I've got two more lines graphed here. And I guess I've not given myself enough space, but that's alright, we'll squeeze it in over here. Alright, so look at this third XY coordinate plane here. You might want to give yourself a little more space beneath these two coordinate planes before you write this down. So we have from left to right, this line looks like it's neither rising nor falling. It looks pretty flat. Alright, and this is what we call a horizontal line. So a horizontal line occurs when we have a zero slope. Zero slope forms a horizontal line. And if you're a skier, alright, you would definitely not want to ski on a mountain that looked like this, right? Because it's completely flat. This is what it looks like in Chicago, where we're from. Right, completely flat, not good skiing. Alright, you're not going to go anywhere. As well, alright, if think about this as the side of a mountain with skiing, you wouldn't want to ski here either, because there basically isn't much of a slope. It's just straight up and down. If you were to be up at the top of the mountain and try to ski, you would essentially just free fall and plummet down. Alright, so that's not fun either. Alright, so what is this called if it's not a zero slope? Alright, there pretty much is no slope because it's straight up and down, so this would be undefined. So you would have an undefined slope here. And an undefined slope basically forms a vertical line. Okay, so now we've got a little pictorial representation of what a positive slope looks like, negative slope, zero slope, and undefined slope. So now we'll be able to classify these lines, meaning saying whether they rise, fall, they're horizontal, or they're vertical, just by looking at the numerical value of the slope and not even graphing it. And you'll see that in a second. So let's scroll on down here. Alright, and these are our directions, and we're just given 2 points. So in order to find the numerical value of the slope, we're going to have to use our slope formula, which we learned in part 1, which is m equals y2 minus y1 over x2 minus x1. We're going to want to find our slope. And you remember I said, doesn't matter which point you start with, you just got to make sure you start the numerator and the denominator leading with the number from the same point. So my y2 here, I'll designate this 2. Alright, so we're going to say this is x2 comma y2. This one's x1 comma y1. So we're going to do y2, which is 2 minus, and in this case it's a coincidence, also 2. My x2 is the value 3. x1 is 4. So we can see 2 minus 2 is 0. 3 minus 4 is negative 1. So we can see 0 divided by negative 1 is 0. So it's neither positive nor negative. Alright, so we can count out these first two. Alright, so do you think a slope of 0 is a 0 slope or an undefined slope? And you're probably saying 0. So m equals 0 is going to give you a 0 slope. So whenever 0 is in the numerator, you know you have a 0 slope. And with a 0 slope, we know we have a horizontal line. So our final answer is we're classifying a horizontal line because m equals 0. Let's try one more. Alright, we'll do number 2, where we've got the point 4 comma 1 and the point 4 comma negative 2. So again, when we're given 2 points and we have to classify the lines, first step is to find the slope. So I'll write down our slope formula again. M equals y2 minus y1 over x2 minus x1. x1. So we'll designate y2 to be negative 2. So we've got negative 2 minus 1. And then our x2 comes from the same point, so we're leading with 4. 4 minus 4. Negative 2 minus 1 gives me negative 3. 4 minus 4 is 0. And we can see we've got a 0 in the denominator, which should always make you question yourself and say, hey, wait a second, you can't have a 0 in the denominator. Alright, so big exclamation point saying this isn't mathematically possible. Alright, because if you try to use your calculator and do 3 divided by 0, it's going to tell you undefined. Alright, so this would give us an undefined slope, which we know is a vertical line. It's a vertical line because m is undefined. So 0 in the numerator is a 0 slope, 0 in the denominator, undefined slope.